So you made an assessment previously by looking at the shape of the distribution, but what I'd like to do is to be able to turn that into a number rather than something you have to look at. Rather than a shape that has to be looked at, we need to quantify it into a single number. The first idea that you had was that you could use the range of the data. You can work that out. There is an Excel function for range, but let's use the functions for the maximum value, and the argument is going to be the whole of the data set, which will be A4 to A5 over 3, and the minimum, the Excel function is minimum, A4 to A5 over 3, and the range of course is just the difference between the two. Put that into the 2000 data set as well. And you can see that the range is wider for the 1999 data than it is for the 2000 data. However, you also recognise that the range is a poor measurement of variability because it only uses 2 data points out of 500. So the next thing that you came up with was a measure of variability that used the whole of the data set. The logical thing to do is to compare every member of the data set to the mean of the data set. So in order to do that, first of all we need to work out the mean or the average of the data set. Again, Excel function for average. The argument, of course, will be the data set itself, A4 to A5 over 3. And then we then need to work out the difference between each of these data points and the average. And we've put a column here for you to do that in. The differences column. So in here we need the formula which is going to take each data point and subtract the mean. There's 2 things that we need to bear in mind at this point. First of all, if we want to copy this formula down, we want to make sure that it always refers to cell C7, which is where the average is. So for that to happen, we need to put a $sign in front of the 7 to make it an absolute reference. Now, if we were to copy this down and then add them all together, by definition we'd end up with a value of 0. The difference between every member of the data set and the mean, if they're all added together, would be 0. So we need to actually disregard the sign in order to get a meaningful number. So we can use the Excel function for disregarding the sign. Just put this in brackets. The Excel function we need to use is ABS, which stands for absolute. So it returns the absolute value of a number without the sign. So when we add all the numbers together, we won't sum to 0. But the sum of those differences, disregarding the sign, if that's a large number, then the variability is larger than if it were a small number. So we can compare 2 different data sets, have a quantitative value to make the comparison. We enter that, and then we copy that down. And here we can enter the sum of the differences. So the Excel function is sum, and the data is E4 to E5 over 3. It's column E that's got our differences in. We enter that. And then if we copy these, we can do that for 2000 as well. Enter the differences first of all. 1999, the sum of our differences was 4,500, and in 2000 it was only 2,300, and that's a clear indication that the variability was higher in 1999 than it was in 2000. If the data sets were of different lengths, if we collected 700 student heights on one year and only 500 on the other year, then there would have been a difference in the value of the sum of differences, which may not have been a result of difference in variability. It may only have been due to the fact that one data set was larger than the other. So there's a requirement to standardise if the data sets are of different sizes. Standardisation would of course be to divide by the number in the data set. So this then is our simple measure of variability. In this case it's not been divided by the number in the data set because they're equal. But if we divide by the number in the data set, divide by 500, then we end up with a number which we can compare from any data set to any other data set. So we've got a standardised measure of variability, which really brings us very close to what we set out to do in the first place. At this point, you should refer back to the text.